So let's look now at graphing trigonometric functions and transforming the sine and cosine graph. Now remember, we've already looked at the sine and cosine in the form a and b, a cos bx or a sine bx, and the a value controls the amplitude, the b value controls the period. And remember, with period, we want to take that b value and convert it to period using 2 pi over b, or if we have the period, find the b value. Now that's going to be important. Well, if we were to transform a function that has more than a and b, but also has a c value, the c value is really just the horizontal translation, just that shifting left-right. The only thing is, when we're working with periodic functions, sines and cosine functions, we call this horizontal translation the phase shift. So the phase shift is now the c value, or the horizontal translation. And it's either just shifted left or right, phase shifted. Well, the d value is still just referred to as the vertical translation. And remember, vertical translation is how far up and down the function has been moved. Now, this vertical translation moves up what's called the midline of the function. The midline of the function now gets shifted up. And this midline plays the role that the x-axis once did before the transformation. And that's going to become a little bit clearer as we look at actually sketching and transforming these functions. But what we have to remember, and we did this with other transformations, we have to make a note here. If there is any coefficient on the x value, if x does not equal 1, we must factor out that coefficient from all the terms in the brackets. So we've done that before. If x is a number, we must factor it out of that c value to find the true phase shift. So let's look at a function and determine all of these properties. Here's our function, y equals 6 cos of 2 pi over 14x minus 2, and we want to determine the amplitude, period, phase shift, and vertical displacement. Well, the first one is pretty easy, the amplitude. Amplitude is just the a value, the number in front of the function. So right away, without much work, we can see that the amplitude is 6. Period and phase shift require a little bit more work, but the vertical displacement, we want to find the vertical displacement. Well, that just corresponds to the d value. How far up and down this has been vertically displaced? Well, the vertical displacement is just 2 units down. So the whole graph has been shifted down 2 units. Well, let's look at the phase shift. And actually, the phase shift is pretty easy here because we only have an x term. There's no bracket, so there's only an x term with the cosine. And that tells us that the phase shift doesn't exist. The phase shift is 0. There is no translation left or right. Well, what about the period? And the period is the one that requires a little bit of work. Remember, period is 2 pi over b. And the b value is that number in front of the x. Our b value is 2 pi over 14. So if we want to determine the period, it's 2 pi over 2 pi over 14, which, if we just do some calculations here, becomes 2 pi times 14 over 2 pi. And in the end, we just get a period of 14. So we can find all of the properties of this cosine function from the equation. Well, let's try another. See if we can determine the amplitude, period, phase shift, and vertical displacement. Now, this is one where we have to be careful, though, because inside the brackets, we have a 2 that must be factored out of both terms inside that bracket. So when we factor a 2 out of 2x, that's pretty easy. We're left with an x. We factor 2 out of pi over 3. Well, what we're left with is pi over 6. So factoring out a 2 leaves us with pi over 6 and minus 4. Now, in this form, we can now determine the period, amplitude, phase shift, and vertical displacement. Well, this time I'm just going to use the letters. A, the amplitude, is 3. Remember, that negative just tells you whether it's a reflection, has nothing to do with the amplitude. The B value is 2. Now that B value, remember, can help us find the period. So the period of this function is 2 pi over B, which tells us the period is just pi. The phase shift, well, phase shift exists in this case. It's now pi over 6. And because it's plus, we are going to the left. And we have a vertical displacement. In this case, again, just reading from the equation, of 4 units down. So we can get our amplitude, period, vertical displacement, and phase shift from the equation. Now that's very important because in order to graph a sine or cosine function, we need the A, B, C's, and D's. We need the amplitude, period, phase shift, and vertical translation. So we first must take an equation and put it in this form and determine all of these properties. These properties will then allow us to graph the function. And as I said before, the first thing we do is write the function in this form. A sine B, x minus c plus d, or if it's cosine, the same idea. Once we have it in that form, to plot the graph, we'll use these steps. Start with the midline. Put on the graph the location of the midline. Once we have the midline, then we can determine from the amplitude the highest and lowest points of the graph, the maximum and the minimum. And we'll label that on the y-axis. We'll find the period, and from the period, that'll determine the interval values we need to split the x-axis into. This is going to be the scale on the x-axis. Then we're going to look at the phase shift and figure out where is the starting point, where does this graph start after it's been phase shifted. Then we'll put our key points on, maximum, minimum, midline, and continue this pattern, working it back to 0 so we have at least one full period of the graph. Well, let's put that all together now. Here is our function. First thing we have to do with our function is get it in the form that we can interpret all the information. So we must factor out that 2, leaving us with x minus pi over 4, and we still have that minus 1. And from that, we can now sketch this graph. If we look back at our steps, the first thing we want to do is plot the midline. So we're going to determine the midline, and we're going to plot it. Well, if we look at our equation here, the d value, the midline, is at minus 1. So we're just going to go down to minus 1 on our graph. We're just going to sketch it in and sketch in a midline, which is our dotted line. There's our midline. Well, now that we have our midline in, let's go back to our steps. Now we want to establish what the maximum minimum is by taking the amplitude and adding it to the midline. Our graph is going to go up 3 units from the midline and down 3 units from the midline. So if our midline's at -1, if we go up 3 units, our maximum on this graph will be 2, and the minimum on this graph, -3, from -1 gets us down at -4. Now we have the maximum and the minimum of this function. Now we want to look at the period to determine the scale on the x-axis. Well, our period in this case, well, let's just do a quick calculation here. Period is 2 pi over 2, which is just pi. So our graph, we're going to split this graph up, and we're going to call this point pi. That's our new scale, 1 period. Well, let's put those 4 intervals on. Halfway through would be pi over 2, which means we actually have a scale of pi over 4, and we can draw that in. There is our scale drawn for this graph. We now have our x-axis, our y-axis, and our midline all drawn in. Now we want to find out, where is this new starting point of C after the phase shift? So this graph, if we look at a sine graph, basic sine graph looks like this. We're trying to figure out what happens to this point, this starting point, after the phase shift. Well, this starting point has a phase shift of pi over 4 and a vertical shift of -1. So it's been shifted to the right pi over 4 and down 1. Let's put that on the graph. Normally, the point would start at 0, 0. Now it's been phase shifted over to the right and down, and here is our new starting point, just like that. Now, once we have our starting point on the graph, now we can just do the key points. Maximum, minimum, and back to the midline. And the key points come from this original sketch of sine. Sine starts at 0, or the midline. It goes up to a maximum, back to the midline, minimum, midline. So we follow that pattern. In this case, we just go over a quarter period up to the maximum of 2. Another quarter period over, back to the midline. Now we go another quarter period over and down to our minimum. And we can continue this pattern. Let's put our quarter periods in here. We continue this pattern of minimum, midline, maximum, midline, minimum, and we could go on forever. What we want to do, though, is go back to our starting point and back up, so reverse the pattern. If we started at the midline, that means the 0 point will be a minimum. And now that we have our key points drawn in, we have gone back to the starting point. We can now sketch one full period. And we just connect the dots with a nice smooth curve. And this gives us a sketch of our trigonometric function, just like that. So a lot of steps to graphing it, but we just break it down piece by piece, and we're going to work more of these examples in class.